Hello my dear viewers, welcome to the tutorial of partial fraction for the students of science. But before studying partial fractions, you need to know some basic for doing that. And the basics are, you need to know the difference between identity and formula. You need to know how to equalize the identity coefficients from both sides. You need to know what is leading variable and leading coefficients. You need to know what is proper and improper algebraic fractions. And finally, that you need to know the simplification and our destination partial fraction. So to learn all of this, stay with us. We're going to discuss all of them step by step, inshallah. So first of all, we're going to discuss about identity. As far as you can see in the screen here, x is equals to x cube. This is true only for the given values, or only for the values x is equals to -1, x is equals to 0, and x is equals to 1. How? If we put x is equals to -1 on the both side of equation, look what you're going to have on the left side. X is equals to -1 as it is equals to on the right side -1 whole to the power 3. Since the index is 3, that means it's an odd number, so the sign will be as it is. That means if the sign is minus, that will be minus. If the sign is plus, that will be plus. That means in both sides, for the value of x is equals to -1, we get -1 is equals to -1. For 0, we get 0 is equals to 0, and for 1, we'll get 1 is equals to 1. And go for the second one, x square is equals to x cube. This is true only for x is equals to 0 and x is equals to 1. Look, if we put x is equals to 0, both sides becomes 0. If we put x is equals to 1, both sides becomes 1. But if we put x is equals to -1, then left side becomes -1 whole square. -1 whole square means +1 because the index is even. On the other hand, the right hand side gonna be -1 whole cube, that means -1. So here left hand side is not equal to right hand side. And the third one, x square plus y square is equals to 0. This is true only for x is equals to 0 and y is equals to 0. As far as you know, if the sum of some squares are 0, then each of the squares are individually 0. So from here we can get it that if we change, or if we take some more other values rather than these specific values, then the left hand side will not be equal to right hand side. Then this kind of expressions or this kind of relations are known as an identity. That means they are equal, 2 or 3 expressions will be equal, but for some certain values of the variable may be x, maybe y, maybe z, etc, etc, etc. But if you look at the screen, for formula, look, x plus y whole square is equals to x square plus twice xy plus y square, x minus y whole cube is equals to, as far as you know the formula, area of a rectangle is equals to length into breadth. Whatever the situation is, that doesn't matter. Whatever the value, whatever the real value of x and y we take, or whatever the value of the variable we take from the real numbers, in every cases this equation will be satisfied. That means in every case, for every real value, the left hand side will be equal to the right hand side. When this kind of situation or this kind of relation is built up, then this is known as formulae. Formulae is the plural of formula. That means identity establishes equalization, or identity establish an equation for a or for some certain value. But on the other hand, formula establishes the equation for all the real values. That is the basic difference between identity and formulae. If you look at the screen, this time we're going to equalize the coefficients of algebraic expressions from both sides. So look here. On the left side, we have an expression a x to the power 4 plus b x cube plus cx square plus dx plus e equal to 5x to the power 4 minus 9x cube minus 6x square plus 7x plus 13. Look here, if we equalize the coefficient, look on the left hand side the coefficient of x to the power 4 is a, and on the right hand side 5, therefore a is equals to 5. Same case for x cube, on the left hand side b, and on the right hand side minus 9. That is why b will be equal to minus 9. Similarly, c is equals to minus 6, d is equals to 7, and e is equals to 13. But if we look at the second example, look here, we are almost have the same questions, but on the right hand side we just are missing something. Look, left hand side is as it is like the first example, but on the right hand side we have 5x to the power 4 minus 9x cube plus 7x plus 13. Look, minus 6x square is not available in the second example. So this time when you're going to equalize them, look, we know that if we multiply anything with 0 apart from infinity, then we're going to have a result 0. So look, equaling like the above one, we're going to have a is equals to 5, b is equals to minus 9, c is equals to, look, we have no x square term. That means c is equals to 0, because if we add 0 with something or if we subtract 0 with something, we're going to have the same result. So if c is equals to 0, then 0x square. Now if you place it on the right hand side after 9x cube, so look, 0x square. 0x square means what? 0 into x square means 0. So here x square remains as it is, but the value of c becomes 0. That means the coefficient becomes 0. And like the previous one, d is equals to 7 and e is equals to 13. This time we'll go for the leading variable and leading coefficient. In any algebraic expressions, the variable having highest index is known as leading variable. If we look at the first example, here we have an algebraic expression p is equals to ax to the power 4 plus bx cube y plus cx square y square plus d. So look here the highest index is for x, which is x to the power 4. Okay, so x is our leading variable in these algebraic expressions. And look, x to the power 4 has a coefficient which is a. Therefore, a will be our leading coefficient. And d, it has no x or no y with it. That means d is not the coefficient of neither of the variable x or y. That means d will be the constant only. Similarly, if you look at q is equals to something something something, look here the highest index is x to the power 4 9x cube plus 7x. That means 4 is the highest index. So clearly, since here we do not have any other variable like the previous one y, so definitely x is the leading variable and 5 will be the leading coefficient. Okay, let's move. This time we need to know what is proper fraction. That means since we are dealing with algebraic fractions, so we are talking about the proper algebraic fractions. Proper algebraic fractions are those fractions where the numerator or the index of the variable in numerator is less than the index of the variable in a denominator. Look at the examples. Look, in the first one we have a fraction 1 by x square. 1 means x to the power 0, because we know something to the power 0 is equals to 1 apart from 0 to the power 0 or infinity to the power 0. So look, x to the power 0 divided by x square. So 0 is less than 2. Definitely is a proper algebraic fraction. Go for the second one. In the second one, thrice x divided by x square minus 5x plus 6. In the numerator, the highest index of x is 1, but denominator 2. So 1 less than 2 definitely is a proper fraction. Go for the third, 9x divided by x into x plus 1 whole square. Definitely, if we're gonna expand the denominator, so we're gonna have x into x square plus twice x plus 1 by expanding formula. Now if we're gonna multiply them, then we're gonna have x cube minus twice x square plus x. That means here in the numerator the highest index of x is 1, but denominator that is 3. So 1 definitely less than 3. Therefore this is also proper. And for the fourth one, the highest index of numerator of x is 2, but if we multiply the denominators, we're going to have x cubed plus x. So the highest index is 3, 2 less than 3. Therefore, this is also a proper fraction. Now we are dealing with improper fraction that you can see in the screen on the right side. In this case, the leading index of denominator will be bigger. For improper, the leading index of numerator will be bigger or equal to denominator. Bigger or equal to denominator. That means here the index of the numerator will either be bigger or be equal to the denominator. So look at the examples. Thrice x square. Thrice x square divided by x square minus 5x plus 6. In the numerator and denominator we have equal number of highest index 2, 2. So 2 equal to 2. This is improper fraction. Go for the second one. In the numerator x cube, and the denominator if we expand we're going to have x cube as well. That means 3, 3. Again improper. In the third one we have x cube divided by x square minus 5x minus 6. Look here, in the numerator the index is 3, but denominator the highest index is 2. So 3 bigger than 2. This definitely improper. And the fourth one, like the previous one, 4 greater than 3. So here we can learn what is proper algebraic fraction and improper algebraic fraction. If our concept up to this is clear, then we can simplify, and if we can simplify the algebraic fractions, then only then we can find the partial fractions. So let's move. This time we are simplifying. So for simplifying we need to find the LCM of the denominator. So look at the simplifications. So step by step, you have already learned it in the earlier class in class 6 or 7. Okay, there are 2 examples of simplifications. Why we are doing simplifications? Because partial fractions is just the opposite procedure of the simplification. That means, look, by simplifying the given algebraic expressions, what do you have? We are given 1 by x plus 1 plus 1 by x minus 1, and by simplifying we're gonna have the result twice x by x square minus 1. Similarly for the second one, 3 by x minus 5 divided by 4 by x minus 3. By doing them, what are you gonna have? 11 minus x divided by x square minus 8x plus 15. But partial fraction will do just the converse or opposite thing. What it used to do? Here you are given the last line, that means you are given the result, that means 11 minus x divided by x square minus 8x plus 15. You are asked to find, you will be asked to split them, to write them in the form of 2, 3 or whatever the requirement in fractions. Okay, just have a look here. In the simplification we're just simplifying that on to get a simplified or minimizing a very small result. But partial fraction on the right hand side, here you can see there are 5 examples. They're doing just the opposite thing. They're splitting the concise form and expand them. Look here we have, by expanding the first expressions we have 2 other algebraic expressions. By second one we get 3 other algebraic expressions. Similarly for the third one we get another 3. Here 1 is also, in the third example 1 is also a partial fractions. Why this one? Because this is improper fraction. For improper fraction we will have 1 here, but not every time. Look here in the fourth one we have a 1 here as well. But if the coefficient of x cube is 2, suppose we have the fractions twice x cube by the same as it is, then we have 2 plus, then by calculating we get some other result. If that is thrice x cube, then we have 3 plus, then the remaining. If we have 4, then 4. That means the coefficient plus, by calculating we get whatever we get. Okay, we'll show the total procedure how to simplify. There are different categories of partial fractions. There are different procedures. So for different conditions we'll solve them in our following lectures inshallah. So to get those lectures, stay with us. and pray for us. Till then, stay well and stay safe. Thank you. Allah Hafiz. Assalamu alaikum wa rahmatullah.